So I'll turn on my frequency counter, uh, my dual trace oscilloscope, and then my signal generator. Okay, so this is the order we are going to work. We'll connect the output of the signal generator. We are going to generate a signal which has a frequency of 1 kilohertz. 1 kilohertz. So, okay, so this is 1 kilohertz. All right. As we set this signal at 1 kilohertz, the next thing we'll do is to we'll connect the output from the signal generator to channel 1 or channel X of the scope. Okay. And what we do is that we select the sinusoidal waveform, the sine wave. All right. So we have it, that's a red channel being displayed. What we can do here is to increase the volts per division. The volts per division for this channel is now 2 volts per division. But because we want to find the peak-to-peak voltage, we have to increase the volt per division so that it will be visible. So I've done that. I've increased the volt per division. And I place it well. So this is good. This is good. What we can do now is to find this is a peak voltage, this peak voltage. Okay, peak to peak voltage. I can also open it a little so that so okay, so we can take it from here as our first. So our first waveform starts from this point, or at this point, and it will end at this point. Starting from here and to end here, that's our waveform. And the peak to peak voltage will be this to that. What we have to do to find the peak to peak voltage is to count the number of boxes from the lowest peak to the highest peak, which is 1, 2, 3, 4, 5, 6, 7, and 8. So our peak to peak voltage is 8 volts, but we have to multiply with the volts per division of this channel, the volts per division of the channel 1. And from this place, the volts per division for channel 1 is 2 volts. 2 volts, 2 volts per division. So the 8 times the 2 becomes 60 volts, 60 volts per division. So we have our peak to peak voltage is 16 volts. 16 volts. Now that we have this, we convert it to peak volts. Peak volts. Peak volts becomes Peak to peak voltage divided by 2 will give us peak volts. So one peak will give us 8 volts. 8 volts as our peak voltage. We have to find the root mean squared value of this voltage root mean squared, which will be peak volts times 0.707 by calculation. But we don't need to use calculation for this right now because we have the equipment which can do which we can use to find the measurement. We found the peak voltage. Now we are finding the root mean squared voltage, and this is by multiplying the peak voltage with a constant which is 0.707. But the voltmeter or the multimeter can be used to measure root mean square value. The unfortunate thing is that the multimeter cannot be used to measure peak to peak voltage. Neither can it be used to measure the peak voltage. So you have to find the root mean squared equivalent of the peak voltage. The multimeter can do that. We just take the output from the signal generator, then we connect it to the input of the multimeter. Then we turn it to AC, alternating current. Then we will do the measurement. So I will do that. I'll connect the output of the signal generator. Use a signal bearer, connect it to the positive, then the negative to the neutral. So we are having, by connecting the multimeter, we are having 5.76. But if we should do calculation, the 8 times 0.707 will give us 5.656, which means there is a little variation because of what? Attenuation and some losses. So the values will not be exactly the same as we do calculation. Moreover, the 0. By connecting this probe to the signal generator value, actually. So we have completed one section of our experiment. The next section is to design AC filters. Having found the AC filters to peak voltage, I will entreat everybody who participated to turn on the notification button and be informed for the next episode. Like this video if you actually like it, and share for others to also get a feel of it. Thank you for participating.